So welcome back to the channel. So in this video we'll see 4-stage binary counter using JK flip-flop, right? So what is the stage? 4 stage. So here what is a flip-flop? JK flip-flop. So how many flip-flops you should use? 4 flip-flop you should use. So I will consider the first flip-flop like this, right? So this flip-flop is having 2 inputs and 2 outputs as we know. So I will write that as here it is J and here it is K and here it is Q and here it is Q bar, right? So I will call it as JK flip-flop, which is number 1, right? So now here, since we should write 4, so we will start with I will call it as flip-flop number A. Instead of 1 we can call it as A, right? So if it is A, it is QA and it is QA bar, right? So now we will give this clock, we'll give this time a negative edge clock. So I will write it as a clock which is negative edge clock is given, right? So now after this we will see the next one, next flip-flop, next block, because it is how many stage? 4 stage. We should consider for this again we should have what? We should have J and we should have K and we should have Q and we should have Q bar, right? So here it is Q. So in this case it is QB, it is QB bar, right? So this is what we are having, right? So now this QA will be giving to the next stage as a clock. The output of the first A flip-flop is given as a clock to the next stage. So it is flip-flop number B, right? So I will speak about what is the condition of this G and K later, right? So now after this we will consider the third one, we will consider the fourth one, right? So third one also same. So consider like this, here we will be having J and we will be having K. It is QC and it is QC bar. Similarly here it is giving like this, so you will be having J, you will be having K. So it is C and it is D, right? So here last is, it is QD and it is QD bar, right? So here it is JK. And here what is the condition we should give for J and K is, we will give both the inputs which are tied to 1. When J and K both are 1 1, what is the type of flip-flop we will call? Usually it is T flip-flop, right? Toggled flip-flop. So we will connect this and we will call it as toggle flip-flop, right? So that is what the condition, right? So here before going for the drawing the diagram, we should write the truth table for JK. When 0 0, no change. When 0 1 0 1, 1 0 1 0, when both are 1 1, toggling Q bar and Q, right? For the fourth condition it is very important, right? When both are 1 1, Q, J and K both are 1 1, because we have taken this condition. When J and K both are 1 1, we have considered what is the fourth condition? It should happen what? Toggling should happen, right? So for that first we will consider this clock, and this type of circuit arrangements, are going to be called by what type of circuits? It is going to be called as asynchronous circuit, and in this case we will call this as asynchronous binary counter, because the output of first flip-flop is given as acting as a clock to the second input. Similarly, the output of this is the output of second is to the third, output of third is to the fourth, which is acting as a clock. Here the outputs of each flip-flop are acting as what? Clock. So it is asynchronous counter. So now it has to count. How to count, that we will see now. For that we will take the help of clock. So I will consider this as a clock, and I have considered negative edge clock. So carefully observe this clock, how it is going to behave, right? Since it is a fourth stage, so I should get how many? 4 means 2 power 4 means 16 combinations of output I should get. What are the outputs? QA, QB, QC and QD, right? So negative edge we will see now. This is first, right? So this is second, this is third, this is fourth, fifth, sixth, seventh, eighth. Like this, it is there, right? So can we draw the remaining, right? So can we draw the remaining so that you can understand 1 and 1 means it is toggle, so that we'll understand the whole picture. So I will go here like this. So here it is, right? So here from this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 13, 14, like this we should see now, right? So this is a negative edge clock we have drawn. It is a clock. For this clock now, what we should draw? For this is a clock now, negative edge. At negative edge, we should see what is going to happen. When negative edge at this point, I should draw. What you should draw? You should draw what is going to be the status of QA, right? What is the status of QA? What is the value of J and K? J and K value are 1. When J and K value are 1, so what should happen? What should happen? It should happen like what is the condition should happen? Toggling. Toggling means the previous condition, if it is Q, Q bar should happen, right? So initially, so I will consider a QA as 0 up to this point, right? So at this negative edge, what should happen? Toggling should happen. Means here it is 0 is there. So now what I will get is 1. This 1 will go up to this stage. So at this case, what should happen? Again negative edge. So it is when both are 1, 1. When both are 1, 1, toggling should happen. Means 1 is there. Now it should becomes what? 0. This will go up to next negative edge clock, right? So at this case, what should happen? Toggle means previously it is 0. Now it should be 1. So this continues. This continues up to the last stage. You can just look at now. Wherever the negative is there, I am drawing. Wherever the negative is there, I am drawing. I am drawing the toggling condition, right? So look at this negative edge, negative edge, negative edge. I am drawing, right? So now this is what? What is this? This is QA. The output of first flip flop is this one. For this also negative edge is there, so that we will draw now. This is the negative edge of the QA, right? So this negative is giving to the flip-flop number B. So when this clock negative edge is triggered at that time J and value K value are 1. So at that time what is the output should happen? Toggling should happen. So when negative edge is there, so at this point I should see what is QB. Up to this point what is there? It is 0. At this point what should happen? Toggling. Toggling means previous is 0. Now what it should be? It should be 1. And it should go up to this stage. And at this stage it should be 0. And at this stage it should be 1. At this stage it should be 0. At this stage it should be 1. Like this it continues, right? So wherever it is negative edge, it is changed from 1 to 0, 0 to 1. That is the meaning of toggling. Next, QC we should draw. To draw QC, what we should do now? Positive and negative edge. We should see the negative edge of this QB. Negative edge of this QB. So means this QB is going as negative edge to the C. So that what you will get? QC you will get, right? So how to draw QC? At this point we should see. So up to this point the value is 0. At this point the QC becomes what? 1. And this will go up to next this. This is my point of reference now. So here it should be 0. And it should go up to this point. And now it is going to be the reference point, right? So now after this it is going to be this. So why it is changing now? So at this point, at this negative edge, this 0 becomes 1. At this 1 becomes 0. At this 0 becomes 1. It depends on this JK and toggling because of 1 and 1 condition, right? When both are 1, 1 and toggling happens, then this output is now ready. What is that output? QC is the output now, right? So now this I should feed it to the last one, so that I should see what is the negative edge for this. So here I suppose I should draw QD means it is going to be 0 up to this part. Then after that it is going to be 1 till the next negative edge, right? So this is how we should get the diagram, right? So how to cross check whether we have drawn correctly or wrong is, now just observe this. For the first one, 0 0 0 zeros are there, right? So I will consider here, I will try to draw that truth table here so that you will understand better, right? So what is this you got? QA, QB, QC, QD. QA is LSB, QD is MSB, right? What are these values initially? All are zeros, right? Then after that, at this stage, what is the value? 0 0, 0 1, right? So it is 0 1. 1 is why? Because QA is 1 now. It is LSB and it is MSB. Next, similarly, you can start observing what is the value. It is 0 0 1 0, right? Similarly, you can see it is 1 1 0 0. So it is 0 0 1 1. Next, 0 0 1 0. So 0 1 0 0, right? It will go on up to the last stage. You can see the last stage here. So here, if I take this part 1, it is 0 1 1, means 1 1 0 1. Suppose if I write 1 1 0 1, so still the board is not shorted, so we have restricted up to this one. So we'll see now what are the equivalent decimal values of this. What is this? 0. What is this? 1 2 3 4, up to what is the last? 8 into 8 plus 4, 12, 12 plus 1, 13, up to 13 we are written. 14 and 15 we are not written because of the board it is not taking the space, right? So we have written up to 13, right? So this is how we have drawn the binary counter with the help of this JK flip-flop as well as this timing waveform followed by this truth table. So QA being the least significant bit, QD being the most significant bit. So now we can start analyzing all these so that you will get the correct values for each. Wherever you take, you are going to get the correct results, right? So these are all the things, whatever I have written with respect to this only you should read. With respect to this only you should read. At this point, what is going to happen? Means at this point, what is going to happen? At this point, what is going to happen? At this point, what is going to happen? At this point, you should read like this. You should read like this, right? So that is how you should read, right? So here it is 1 1 0 1. It is 0 1 0 1, right? 0 0 0 1, right? So it is nothing but 8 9 10 11 12 13. So here it is 0 1 2 3 4 5 6 7 8 9 10 up to 13 we have written. Similarly 14 and 15 are missing. Okay, thank you. We'll see in the next video for the next update. It's about the 4-bit binary counter, asynchronous counter, because I told the way. Thank you. We'll see in the next video.